All right, I'm going to go ahead and get going. I was just told that actually Maxthon has canceled and they're not going to be here. So if I go on for longer than I seem to, that's why, because I get to fill their time, I guess. So good morning. I'm Chris Wilson. I'm a developer advocate at Google. I work on the Chrome team. And I'm here to talk about Chrome and particularly kind of JavaScript and programmability in Chrome. So there are three main things I'm going to talk about. JavaScript improvements itself, specific to the language or the runtime, that sort of thing. A bunch of new API areas, which if you caught Eric Beidelman's talk just now, you caught most of those, although not all of them. And I'm not going to go into as much depth or do as sexy demos as he did. And then finally, a couple of other stuff that I want to talk about briefly. So in Chrome, our JavaScript engine, for those of you who don't know, is called V8. V8 has three real main priorities. These aren't actually in a prioritized order. If anything, they're in reverse order. ECMAScript 6 Harmony modules, so new language features of JavaScript. I'll talk about some of those in detail. Conformance with ECMAScript 5, with the Test 262 suite, and of course, performance. So ES6 features, there are 4 features that we've actually turned on in V8. They're all under flags right now, so you have to go turn them on in developer flags in the developer channel. The first one is the lexical scoping features. Brendan actually talked about these earlier. This is let as the new var and also const. Const is obviously an immutable version, but both of these are actual block scoped bindings. This means it's harder to screw things up. It's harder to write code like the middle bit of code that even if you used var there, it probably didn't make any sense because you were scoping it incorrectly and you're going to end up with a global. We also have turned on collections. Collections are sort of a more efficient map. You can use anything as any value as a key, including objects, which makes lookups very, very quick and easy. We also have weak maps, which I'm not going to go into a ton of detail on just because they're very specific. They're a special kind of map that interacts with the garbage collector in an interesting way. This helps you avoid memory leaks and long-lived tables, but it really is a pretty advanced feature. And finally, proxies. Proxies are a really handy feature. Proxies let you simulate a JavaScript object. It lets you insert yourself in between the JavaScript runtime for the object, the implementation of the object, and outside code. So you get to add new features, change the behavior of a current object, that sort of thing. There are all kinds of advanced abstractions and interesting ways to use this. But I don't want to just cover the things that we've already done. I wanted to briefly mention a bunch of the things that are in Harmony. Don't take this as these are less important or less interesting. Some of these are pretty well-baked. A few of them are not very well-baked. These are things, for the most part, we will be working on in the future. We just haven't gotten around to them yet, for the most part. So lots of things to come in Harmony. I'm certainly not the Harmony expert. That would be Brendan. So function improvements, generators, iterators, all that kind of stuff. Lots of modularity improvements. On ES5 conformance that I mentioned, we're just continually chipping away at ES5 conformance. We now have almost all of the failures in Test 262 fixed in our code, so that we will run the entire Test 262 suite, except for the things that, for one reason or another, we're supposed to fail right now. And finally, of course, performance. Performance in JavaScript is a many-splendored thing. We really do focus primarily on optimizing real-world performance. That's why we have our own test suite that we try to track real-world optimizations there and continually improve. Obviously, the real world has a very varied set of situations and scenarios, so that can be a hard thing to do. But we try to find new ways that affect that. Occasionally, these show up in test suites as well. One recently that we did was moving from using a timer, basically, to determine when a function should be optimized or should be compiled using our optimized compiler rather than our fast compiler. Rather than using time to do that, we now use a counter. So if a function has been iterated past several times, it will fire off into the optimizing compiler which of course is slower, but now we know that it needs to be done. This gave us a really healthy SunSpider improvement. Because this is the way that SunSpider tests usually, it's very small loops. And a lot of SunSpider tests would complete before our timer would even fire. This happens in the real world as well, although not quite as much as in SunSpider, I think. So moving on from JavaScript, the language, and kind of our JavaScript runtime, the more exciting thing to me is really the wealth of APIs that are showing up for building JavaScript programs on top of. These are things like offline, the file system API, the index database API. Eric talked about a lot of this stuff in his talk just now, so I hope you caught that. Lots of interesting things showing up in media, WebRTC for doing video conferencing, image, video, and audio capture. My personal passion and favorite is the Web Audio API, which lets you not only access audio input and output, but also do all kinds of audio processing, so building a synthesizer or doing effects audio processing or things like that. If you didn't catch it, there was a Moog doodle that showed up on Google last week, I think, that was basically implementing a Moog synthesizer. And they actually only used the Web Audio API for output in that particular case, but you could actually build most of that using the API itself. We've done a ton of work, as most of the vendors have, on developer tools. I would really recommend seeing Paul Irish's talk on this. I think it's tomorrow morning, or maybe later this afternoon, I can't remember. We've also done a ton of work on web components, which is very early still, I think, but being able to do better semantic capturing of controls and componentizations. You don't have to do as many weird tricks with iframes and that sort of thing. And mutation summaries, which will help enable faster data binding and other editing things. One of the really super powerful things, which actually I hadn't used before until I started really getting into the Web Audio API, was getting typed array access to data. Obviously, in Web Audio, this is something you want to do all the time. Like, all of your data is basically sound buffers. Sound buffers are always, floating point data in a huge array. You don't really want to change how they're allocated or anything. They're just a contiguous block. So I started using array buffers a lot. They turned out to be incredibly useful in a number of scenarios, textures in WebGL, as well as Canvas image data. And of course, when you want to transfer objects across to workers, they're super useful as well. I'm not really going to get into CSS and design features. There are a ton of interesting things there, but they're not really as directly programming experience related. We also have started doing some stuff about hooking web applications into the user experience with web intents. That's kind of an interesting way to start letting web applications get closer and closer to the native user experience. And Eric also talked about transferable objects earlier, having much, much faster ability to pass ownership across to a web worker or a new window. And that really will help, I think, building multi-threaded programs. There are a couple of sort of gaming-targeted or gaming-inspired APIs that I also wanted to mention. We have a pointer lock API now. This is tied together with the full screen API, which lets you do things like take your web browser full screen. Gamepad access, which Firefox, I think, initially implemented, but has gone to Chrome and other browsers now as well, which gives you the ability to plug a gamepad into your, or connect a gamepad to your browser and get access to all of the gaming API. And then, of course, request animation frame and page visibility for doing better animation, not using set timeout to do animation. If you're still using set timeout to do animation, please look up request animation frame. It's much better all around. It's smoother. It also uses a lot less power. And finally, in the other category, two things I actually kind of tweaked these slides a little bit more and expanded them after Brendan's talk this morning. Native client. So native client is an open source tech for running compiled code inside a sandbox in the browser. It maintains OS portability, although it doesn't currently do processor portability. So if you have an Intel processor, it can run that code on the Intel processor that was compiled using C and C++. But it also puts you in a sandbox so you don't have all these calls out to dangerous OS APIs and that sort of thing. This is really a great thing if you're trying to easily port or quickly port an existing application. Games think this is great a lot of times because they have big engines that are built in C++, and they don't actually want to go re-engineer all of that off the top of or in order to get running at all. This is not intended to supplant the web platform in any way. That's kind of not really the point at all. It's sort of just another option for running current code. And then Dart. If you're interested at all in Dart, go see Seth Ladd's talk. Seth is an expert on Dart. Dart is a language, a set of libraries, an editor, a virtual machine, and most importantly, that compiler to JavaScript. We actually do expect that a lot of people will be using the JavaScript compiler with Dart. Like that's what they're going to, that's going to be their output, their runtime is going to be that compilation to JavaScript step. The whole point of Dart as a language is to provide an option for larger scale applications, some features that JavaScript really doesn't center around. So it's a great kind of way to go for that. And with that, I'll take any questions if anyone has any. Yes?
Early on, you were talking about the counters versus time for the compiling optimization.
Mm-hmm.
Is it possible to use like a hybridized approach to that, or is it one or the other?
Well, so what we actually do is a hybrid approach. What we're doing is we basically have two compilers, and we compile all code that comes in using a very fast compiler. However, it's not very efficient, and what we really what we're trying to do is intelligently choose what code we want to use the fast compiler on. Sorry, not the fast compiler, the optimizing compiler that writes very fast code. So this lets us switch in between that based on the number of iterations of usages of the function rather than some timeout. Before, I think we had a 1 millisecond timeout before we said, OK, how many times have these functions been used? And let's go recompile them now.
And how did you get to that magic number? Was it some heuristic, or was there
So previously, I think it was basically a magic number of a millisecond. Now it's actually, I don't know what the exact number is, but it's some set of iterations of the function. So it actually tells us, hey, this function's been called 500 times. Maybe you want to go optimize it now. Whereas before, it really was kind of a magic number. And we would get bad interactions because of that. Like particularly on SunSpider, where all of these tests, half of them finish in under a millisecond. Or they'll be half done with their iterations in a millisecond. So it doesn't really help us there at all. Because by the time we think about, hey, maybe we should use the optimizing compiler, it's already done. And we're just wasting time. Yes?
You were talking about the real-life performance test of the browser. Is that something that is publicly available?
So the real-life performance testing of the browser, yes, we do have our crap, I'm blanking on the name now. We have our test suite out there. And it has been public, actually, for 2.5 years, I think, something like that, that we use for V8, and other vendors run it as well. So it's really, the more test suites, the merrier in terms of JavaScript performance, I think, because they all end up with different takes on what constitutes real-world performance. I also think that changes over time. Yeah?
So it was heavily focused on Chrome and APIs
Mm-hmm.
it's going to implement. And then you mentioned Dart at the very end. Is there any kind of maybe special relationship that's going to happen with Chrome and Dart? Or is it just going to be out there as a language?
So is there any special relationship that's going to happen with Chrome and Dart? So at some point, yes, I do expect that we will probably, presuming that it continues to be successful, move the Dart virtual machine into Chrome. It currently is not. We have a side project that is a build of Chrome called Dartium that has the Dart virtual machine running in it. If you don't want to use that, you compile to JavaScript, and it works just fine in pretty much any browser. That really is going to end up being market-driven, I think. Like, if it seems like a really useful tool and people want to use it, then yes, we'll push it in there, but it would have to be worth putting the virtual machine in. And of course, even once we do that, developers would have to choose when they want to optimize for that case versus the JavaScript compilation case. Other questions? Yes? Oops.
Earlier this year, there was some articles in CNET about native client. There was one that said it's going to be canceled, and then one that said it's not canceled. Is there any insight you can offer on?
Okay. Is there any insight as to whether native client has been canceled, going to be canceled, whatever? The only insight I can offer is I know it has not currently been canceled. I do not believe that it is likely to be canceled, frankly. It's actually a really useful project, and if you go and look, there are quite a few. It is particularly useful for the scenario of games, because there are a lot of games out there that have written very, very highly optimized engines in C and C++ that they would like to just push out to web users as quickly as possible. So that's currently a big scenario for it. If you go on the Chrome Web Store, there are a lot of 3D immersive games that are built that way. I don't think we would be at all likely to cancel that. Certainly not in the short term. Now, in the long term, of course, it will come down to what developers latch onto and use. And there is the problem that it currently only works on Chrome. So you're limiting yourself to Chrome users when you use native client. But at the same time, the carryover to native application then is usually pretty easy too. Other questions? Well, we have a lot of extra time since Maxthon canceled, so we're all right. Yeah, please. I got 20 minutes, I was told, to kill. So
The counter-based optimizer in VA.
Mhm.
Does that mean that there's no other? Normally, you would see two threads. One is the tick counter that looks at the stack or whatever. So that process goes away with the counter-based.
So with the counter-based approach, I don't believe we watch for the ticks anymore at all. I could be wrong. It could be that we're actually looking to see that for some other reason. But I know the main way that we choose when to run the optimizing compiler is no longer on a background timer. It's on a tick count that we watch changes to. Yeah?
What was the Maxthon going to be about? I've never heard about it, and was it meant to complement your talk?
So what was the Maxthon talk going to be about? Was it meant to complement my talk? So no, it wasn't meant to complement my talk. Maxthon is actually a browser that's been around a long time. It's very popular in China. It's built in China, I believe. It used to be built on top of the IE engine, but I believe they've lately been doing a lot more enhancements to it other than that. So I'm not entirely sure what their content was going to be for their talk, though. Is there another question back there? Yeah?
Well, so you mentioned some ECMAScript 6 features that
Mm-hmm. Yes. Do I know when weak reference is going to be added? I'm not sure which feature you mean.
Well, the ability to handle an object that doesn't extend the object lifetime, release.
Yes. So I was under the understanding, I haven't actually used it myself, so I can't state that unequivocally. My understanding was it's in there under a flag. So you have to go into the dev or canary channel, and you have to go in and turn on the experimental JavaScript features. That's where we're currently putting all of the ES6 stuff that's not completely rock solid in the spec. Okay, well, I guess we can all go get early seats for lunch unless there's any other questions. Cool, thanks.